Assalamualaikum warahmatullahi wabarakatuh. To my lecturer, Madam Norshan binti Yusof, and to all the person who watched this video. My name is LUQMAN bin Muhammad Zaki. The other friend is Ku Muhammad Fitri bin Ku Zamri and Azrun Shamil bin Muhammad Ali. So today I will conduct an experiment 3 video presentation for DC circuit. For objective, first is to measure the current and voltage simple DC circuit. Second is to study series connection of resistors. And lastly, to study parallel connection of resistors. So for procedure, it divides into 3 parts, which are first is measuring the current and the voltage in simple DC circuit. And the second is series connection of resistors. And lastly, for parallel connection of resistance. And here is the procedure for part 1. Continuation for procedure for part 1. Procedure for part 2. Continuation for procedure part 2. And lastly for procedure for part 3. Let's move to data calculation and result. Part 1. Measuring the current and the voltage in simple DC circuit. These trials are required to record this table. When the voltage is 10 volt, the current is 1 ampere. When the voltage is 20 volt, the current is 2 ampere. And lastly, when the voltage is 30 volt, the current is 3 ampere. In all these trials, resistance is constant, which is 10 ohm. The calculation of R equal to V over I in all these 3 trials is 10 ohm. And here is the graph for experiment part 1. For part 2, series connection of resistors. Based on the result, the value of 48 volt was recorded after connecting the voltmeter across the resistance R1. Meanwhile, 72 volt was recorded after connecting voltmeter across the resistance R2. After totaling both of the value V1 and V2, we got the same value as V total, which is 120 volt. It is shown that electric current I are all constant in the circuit because in series circuit, the charge keep flowing through every component in the circuit. After calculating I multiply R1 and I multiply R2, both have the exact voltage value for each V1 and V2, which is 4. V1 is 48 volt and V2 is 72 volt. And here is the graph for part 2. For part 3, parallel connection of resistor. So, based on the result, value for V1, V2 and V total are the same, which is 120 volt. Since the value of voltage is going to be the same if it is parallel circuit, which means that the voltage is still the same over every component in the circuit. And here is the data calculation and result for table 4. I1 is 6 ampere while I2 is 4 ampere. When these two combine, it will give the total current, which is the same as I total in the circuit, and that is 10 ampere. The reason why these two have different value of current because there is different resistance in each branch in this parallel circuit. So this is the graph for part 4. For discussion, for experiment part 1, a series circuit was created using the simulator, which included a resistor, battery, ammeter and voltmeter, all connected via wires. The voltage is changed from 10 volt to 20 volt and eventually to 30 volt to manage the battery. According to the data and graph above, as the potential difference increases, so does the current. The resistance, on the other hand, remains the same. This demonstrates that I equal to V over I, V over R. Alternatively, if the resistance in a circuit rises while the voltage remains constant, the current will decrease. In experiment part 2, the two resistors were connected in series. The voltmeter was connected across the resistor because voltmeter cannot be connected in series because it has high resistance and current will not flow through it. The results show that voltage at R1 is lower than the voltage at R2. This is because the resistance of R1 is lower than resistance at R2. High resistance means high voltage needed to make sure the current can flow through the resistor and the circuit. Next, the result also shown that the current is same whether the emitter was connected before R1, between R1 and R2, or even R2. To make it clearer to understand, the current that flows in circuit before it passes through R2 and the current that has passed through the R1 is the same. The same current that has passed through R1 will pass through R2 too. This is because there is no other path to travel but to pass through next resistance. This is how current remains the same. According to the results of the third experiment, when resistors are linked in parallel, they all experience the same voltage. As a result, the battery's full voltage was applied to each resistor. V total equal to V1 plus V2. While current flows in parallel circuits, it does not flow at the same rate. As a result, total current leaving the battery is split into two branches. I1 plus I2 equals I total. Because the battery voltage was high up to 120 volt, the resistance of the wires was set to 20 and 30. Otherwise, the circuit would burn. There aren't many mistakes because this is an online experiment. Human error, on the other hand, is the most obvious, as it is a personal gaffe committed by the individual. A defective circuit connection is the first. Current is measured with an emitter, for example. The emitter must be connected in series to the circuit. The current reading will be wrong if it is connected incorrectly, and the emitter will be damaged. As a result, make sure the emitter is connected to the circuit at all times. Second, reading mistakes are common as a result of not paying attention enough when taking measures. Therefore, to get more accurate values, we must repeat it for 2 or 3 times or let 2 or 3 persons read the measurement together. Lastly, for conclusion, to conclude from this experiment, direct current is a type of current which flows in one direction. The flow of direct current in a circuit can only be accomplished when the circuit is closed, but the flow of current ceases when the circuit is open. To link the component, a simple current requires a power source that supplies a current certain of voltage as well as a wire. To open or close the circuit, a switch is used. In a DC circuit, the voltage supply produces a potential difference that induces the flow of current. The higher the voltage, the greater the current. The relationship is outlined by Ohm's law. That is all from me. Thanks for watching. Have a great day ahead.